Welcome, Algebra 1. This is 7.2 through 7.4. Laws of exponents continued. The essential question is, what laws of exponents are in this section? Let's begin. So we finished up, in the last video we did these top two. The bottom video we're going to do these bottom four. And I'm just going to go through these quickly and we'll do more examples in class, but I just want to get you the basic idea of what's going on. First one, multiplying powers with the same base. So when I say same base, the number on the bottom is the same. So a to the m power times a to the n power equals a to the m plus n. Basically what you're doing here is you're going to add exponents. So you're going to write that down. You're adding exponents. So you need the same bases and they need to be multiplied here. If this was addition, that wouldn't work. So in this, let's try these examples right here. 3 squared times 3 to the 1 power is going to be 3 to the 2 plus 1 power because it's the same base. So that's 3 to the 3 cubed, and 3 cubed is going to be 27. 2 to the 5th power times 2 to the negative 4 power will be 2 to the 5 plus negative 4 power, which 5 plus negative 4 is going to be 2 to the 1st power, which is just 2. And the bottom one, 4 to the 3rd times 4 to the 2/3 power, well, that's going to be 4 to the 1/3 plus 2/3 power. And if you add that up, you get 4 to the 3/3 power, which is the same thing as 4 to the 1st power, which is just 4. So that's how that works. When you're multiplying two powers of the same base, you add the exponents. Next one, power of a power. So a to the m, all of that to the n power. So when you have a to the m to the n power, you can write that as a to the m times n power. You multiply in this case. So why does it work in this case? Well, I kind of look at like, oh, anyways. So that's the example right here. So a can't be 0 and m and n are rational. So let's do some example here. 5 to the 4th power squared is going to be 5 to the 4th times 2, which is going to equal 5 to the 8th power. M to the 3rd power, all that to the 5th power, is going to be m to the 3 times 5 is 15th power. The next one, a to the 3/2 power cubed, is going to be a to the 3/2 times 3, which is a to the 9/2 power. That's how you do that one. Let's go to the next one. Power of a product. So it's very similar here, except just instead of just having one number variable in here, we have two being multiplied. So ab all to the power of n equals a to the n times b to the n. I think of it like distributing in this case. So you're distributing that power to both numbers or variables inside. So the n's going to the a and the n's going to the b. So let's do the examples here. 3x all to the 4th power becomes that 4 is distributed. So it's 3 to the 4th times x to the 4th, and 3 to the 4th power is 81. So it's 81x to the 4th power. The other example, you distribute this 3 to both the y and the z, but here's how this turns out. It's y squared, all of that to the 3rd power, times z to the 3rd power. Y squared to the 3rd power, that's just the power of a power we talked about last time, so it's going to be y to the 6, 2 times 3, times z to the 3rd power. Those are those examples. Let's do the last one. A quotient of powers. So this is where you take two numbers, they have the same base here, but so a to the m power over a to the n power, you subtract them. It's the same thing as a to the m minus n power. So you're subtracting in this case. So for some examples here, 2 to the 6 over 2 squared is the same thing equals 2 to the 6 minus 2 power. 6 minus 2 is 2 to the 4th power, and 2 to the 4th power is 16. For this example down here, x to the 4th over x to the 7th, that's x to the 4 minus 7, and 4 minus 7 is negative 3. And we know about negative exponents, you're going to flip it to the denominator, so it becomes 1 over x to the positive 3. And that's how you do those. So let's try some examples. So simplify. Pause the video. Okay, so we're combining a few powers here. I'm going to multiply 4 times 9 first, and that's going to be 36. And then it's 36 times z to the 5th times z to the negative 12th power. Those z's with the same base and different exponents here are going to combine. So that's 36 times z to the 5 minus 12, which is going to be negative 7 power. And I want to convert that to the bottom, so this is going to be 36 over z to the positive 7th power. Let's try another one. Pause the video. All right, these are powers of a power. So this first thing is 2 to this power. I'm going to multiply those together. That becomes x to the negative fourth power. This is power of a product here. So this 4 is distributed to the y, the x, and the 3. So this is going to be times 3 to the fourth power times x to the fourth power. Since it's y to the fifth, that's y to the fifth times 4, so y to the 20th power. All right, I can combine those x's here. So the x with the same base and that same base is going to combine to x to the negative 4 plus 4 power, which is x to the 0 power. So those basically just go away. And all I'm left with is 3 to the fourth power times y to the 20th power. And 3 to the fourth power is 81, so it's 81 y to the 20th power. Let's try another one. Pause the video. Okay, and there's more than one way to do this. So it's quotients here, right? So it's going to be, this is like k to the 1 power. So this is k to the 6 minus 1 power times j to the 2 minus 5 power. That's a times. So it's going to be k to the 5th power j to the negative 3 power. And that j is going to be, since it's negative exponent, we're going to put it on the bottom of the denominator. So it's k to the 5th power over j to the 3rd power. And that's your answer. That's it.